Today we will learn stadia survey or tacheometry survey. Tacheometry is the type of surveying in which vertical and horizontal distances are computed from stadia readings without using chain or tape. This is done by the help of a special type of transit theodolite known as tacheometer and a staff known as stadia rod. Stadia. The stadia diaphragm essentially consists of one stadia hair above and the other at equal distance below the horizontal crosshair. The stadia hairs being mounted in the ring and on the same vertical plane as the horizontal and vertical crosshairs. Figure 8.1 shows you stadia diaphragm. Figure 8.2 shows you different forms of stadia commonly used. Principle of tacheometry. In stadia tacheometry, the line of sight of the tacheometer may be kept horizontal or inclined depending upon the field conditions. In case of horizontal line of sight, the horizontal distance between the instrument at A and the staff at B is D is equal to F by I into S plus F plus D. D is equal to Ks plus C. The value of F plus D is called the additive constant, that is C, while F by I is called the multiplying constant, that is K. Tacheometry can be used on horizontal or inclined sides. This lecture focuses on horizontal sides. Tacheometry equation for horizontal sides: D is equal to Ks plus C. S is equal to staff intercept equal to St minus Sb, where St and Sb are top hair and bottom hair readings respectively. K is equal to multiplying constant of tacheometer. C is equal to additive constant of the tacheometer. D is equal to horizontal distance between the instrument at A and the staff at B. Operating principle of a tacheometer. In a theodolite, if two additional wires are placed symmetrically on either side of the horizontal crosshair, the horizontal distance or vertical difference in height from the center of the instrument to the stop point can be found out without actually measuring it. Such a diaphragm with additional horizontal wires is called a stadia diaphragm. The constant of the instrument depends upon the stadia interval, that is the interval between two stadia wires. Normally there are two constants. 1. The multiplying constant K, normally kept at 100 or 150. 2. The additive constant C, the value of which varies from 20 to 30 cm. This value is greater in external focusing telescopes and smaller in internal focusing telescopes, and sometimes quite negligible. By imposing an additional lens in the telescope, the additive constant can be reduced to zero. Such a lens is called an analytic lens. By observing the vertical angles, if any, from the instrument to the stop point, the horizontal distances and vertical height can be computed by applying proper equations. Significance. Through this fieldwork, student will learn about indirect measurement of horizontal or inclined distances. It is particularly useful where it is difficult to pass a measurement instrument along the terrain to the target place up to which the distance is to be measured. Determination of tacheometric constants. Set up the instrument on fairly level ground giving horizontal size to a series of pegs at known distances d from the instrument. Now using the equation d is equal to Ks plus C. Analytic lens. An additional lens is sometimes placed between the object glass and the eyepiece of the telescope in order to eliminate the additive constant F plus D. This is done to make the expression for the distance d between instrument station and stop position more simplified. The analytic lens is provided only in an external focusing telescope but not in the internal focusing one, which is virtually analytic since the value of F plus D is very small. This arrangement simplifies the calculation of heights and distances from fieldbook, especially for inclined sights, but the drawback is that it reduces the brilliance refulgence of the image due to absorption of light.